The lesson today is on classifying quadrilaterals. A quadrilateral is a closed figure with 4 sides and 4 angles. Now a closed figure means that the 4 lines meet. Okay, there are no open gaps. It has 4 sides, 4 angles, and it can be named based on the sides and the angles. So we have 2 diagrams here that show the most common ways that quadrilaterals can be classified. The most important is this flowchart that you see on this first page. At the top of our flowchart we have the quadrilateral. Now it just has the general definition that it has 4 sides and 4 angles. There are a couple of major types of quadrilaterals. One is the trapezoid. Over here we see the trapezoid. So we have 2 little arrows, one down here on this line, one up here on this line. And what these arrows mean is that these 2 lines are parallel to each other. Now each of these lines has 1 arrow. That means that this line with 1 arrow is parallel to this line with 1 arrow. Okay, so that's why we have the single arrows on this particular figure. The definition of a trapezoid is a quadrilateral with exactly 1 pair of parallel sides. It can't have 2 pairs of parallel sides. It can't have 0 pairs of parallel sides. It has exactly 1 pair of parallel sides. So that's our trapezoid. Now over here, our other major definition of quadrilateral is underneath parallelogram. Now you'll notice on this parallelogram that we have 2 pairs of parallel sides. So we have single arrows here for this line and this line. That means that these 2 lines here are parallel. But you'll also notice we have 2 arrows here and 2 arrows there. That means these 2 lines match and are parallel. Okay? So the double arrow line is not parallel to the single arrow line. Obviously, they meet, and so therefore they can't be parallel. So we separate which lines are parallel by the number of arrows they have on them. So these 2 have single arrows, they're parallel. These 2 have double arrows, they are parallel. All right, so that's our parallel lines, and a parallelogram has 2 or both sets of lines are parallel. The opposite sides are parallel. Okay, so in a trapezoid we had 1 set of opposite sides parallel. In a parallelogram, both sets of opposite sides are parallel. Now in a parallelogram, both sets of opposite sides are also congruent. And if you recall, congruent means that they are equal in length. They're equal. Congruent is equal. Okay, so a parallelogram has 2 sets of congruent sides. The opposite sides are congruent. Now the way that we know that they're congruent, looking at this picture, is we have 1 little hash mark here and 1 there. Since each of these have 1 mark on them, that means that they are equal in length. And then you'll notice our other set of opposite sides has 2 marks, 2 hash marks here, 2 hash marks there. That means that these 2 are equal in length. All right, so a parallelogram, its definition is that it is a quadrilateral with both pairs of opposite sides being parallel and congruent. Now underneath parallelogram, we have some other specialty categories here. So parallelogram has some specialties under it, and some of our specialties include the rectangle. Okay, a rectangle is a parallelogram. The opposite sides are congruent length. The opposite sides are parallel, but the special situation here is that there are 4 right angles, and you'll see the right angle marks in all 4 corners. Okay, so the special situation with the rectangle is that it has 4 right angles. Now there is also a subcategory for rectangles. A special kind of rectangle is a square. Now a square is also a parallelogram. You can see the dotted line coming down from parallelogram. A square is a special kind of parallelogram where all 4 sides are the same length. You see you have 1 single mark on all 4 sides. That means all 4 of these sides are equal to each other in length. And then we have the right angle marks in all four corners. So a square has 4 equal sides and 4 right angles. And y'all already knew that, but we're just defining the subcategories here. Now also under parallelogram, aside from the rectangle, we have the rhombus. Now a rhombus is a parallelogram. It has opposite sides parallel. Opposite sides are congruent or equal, but the special case of the rhombus is that all 4 sides are equal length in this case. So we don't have 90-degree angles in the corner, but we do have 2 opposite parallel sets of lines, and we have 4 equal measurements on our sides. So it's kind of a square in a diamond format. Now, because this rhombus is more general, all it's saying is that it's a parallelogram with 4 equal sides. A square is also a special kind of rhombus. So square gets to be a special kind of rectangle and a special kind of rhombus. And the reason that it's a special kind of rhombus is because a parallelogram with 4 right angles and 4 congruent sides is the definition for square. Well, if we took out the 4 right angle part, we would have a rhombus. So all we're doing is taking a rhombus and giving it 90-degree angles, and that makes a square. All right. So when we're looking at this flow chart, you're going to be answering some questions about sometimes, always, and never. Is a rectangle sometimes a square? Is a square sometimes a rectangle? What we're looking at here, starting at the top with quadrilateral. All right, a quadrilateral sometimes is a trapezoid and sometimes is a parallelogram. So we've got 2 choices with quadrilateral. Sometimes it's a trapezoid, sometimes it's a parallelogram. Trapezoids kind of end there. They're their own little category. Our category of parallelogram, though, sometimes a parallelogram is a rectangle, sometimes it's a rhombus, sometimes it's a square. Okay? So going down, if you haven't noticed already, this is a sometimes relationship. Okay? Now, a rectangle is sometimes a square, and a rhombus is also sometimes a square. Okay, so going down, we have a sometimes relationship. Quadrilaterals are sometimes trapezoids and sometimes parallelograms, etc. Now, if we start at the bottom with a square is always a rectangle. And it's also always a rhombus, and it's always a parallelogram. Okay, so squares are always classified, can always be classified as rectangles, rhombus, or parallelogram. Okay, it's a very special kind of each of those 3. Now a rectangle is sometimes, or I'm sorry, always a parallelogram. Parallelograms sometimes are rectangles, but a rectangle is always a parallelogram. Okay, and a rhombus is also always a parallelogram. That's in its definition. A rhombus is a parallelogram with 4 congruent sides. A rectangle is a parallelogram. So it's always going up. Anything going up this flow chart is always. Okay? A parallelogram is always a quadrilateral, and a trapezoid is always a quadrilateral also. Now, if there is no relationship, no line on this flow chart connecting 2 things, then that is a never relationship. Okay? So there is no line between trapezoid and parallelogram. Okay? That means that a trapezoid is never a parallelogram. There is no line connecting rectangle to rhombus. A rectangle is never a rhombus. Okay? So reading this flow chart, you can figure out sometimes, always, and never. There's a couple of special shapes, actually one special shape that we'll be talking about with quadrilaterals, and that is a kite. Now a kite is just a plain old quadrilateral, but the special thing about a kite is that it has 2 sides that are consecutively the same length. So these 2 are the same length. Okay, they're right next to each other, they're adjacent. And then these 2 are the same length and they're adjacent. So it has 2 sets of adjacent sides that are the same length. Same thing with this kite. So you might sometimes call that a kite, and you might sometimes see that written in your work. Okay, so there's definitions of quadrilaterals. Now, let's talk about classifying them. Here is a Venn diagram. All right, so we should not make assumptions about whether a line is parallel to another line or not. It either has the parallel markings or it doesn't. It has congruent measurement markings or it doesn't. And it has 90-degree angle markings or it does not. So never assume that something has a 90-degree angle unless you're told in the directions that you can assume that. Don't assume something is a parallel line unless you're told in the directions that you can assume it. So practice classifying up here. What do you think number 1 is? Number 1 is a rectangle. Number 2, is a quadrilateral. It does not have any parallel sides at all, so it's a plain old quadrilateral. Number 3 is a parallelogram. Opposite sides are parallel and opposite sides are congruent. Number 4 is a rhombus. It has 4 congruent sides, but it does not have 90-degree angles, so it's not a square, it's a rhombus. Number 5, that's that special case we called a kite. You might also call it a quadrilateral. Number 6, we're going to call this a parallelogram. One thing you can assume is that if your opposite sides are equal length, then they almost have to be, well, they do actually have to be parallel. There's no way to draw opposite sides of equal length, 2 sets of opposite sides equal length without it being parallel. So if you have your opposite sides of equal length, they must be parallel. Okay. All right. Determine whether each figure can be drawn. Can you draw it? And if you can't draw it, why not? So you could actually try to draw it. A quadrilateral that's both a rhombus and a rectangle. Well, if we look back at our chart, our flow chart, is there a quadrilateral that falls underneath rhombus and underneath rectangle? And yes, there is. It is the square. Okay, so back here, a square is both a rhombus and a rectangle. A trapezoid with 3 right angles. Well, a trapezoid has only one set of parallel lines. If we are going to draw something, now remember, a quadrilateral has to be a closed figure. You can't leave open gaps, okay? So we can't draw a quadrilateral like this, okay? It has to close up. So is there any way to draw a trapezoid where only one set of the lines are parallel with 3 right angles? No. If it's a closed figure, it's not possible. Okay? And then a trapezoid with 2 congruent sides. Yes, you can draw this. And it's called an isosceles trapezoid. You don't necessarily need to know that this year. But an isosceles trapezoid has one set of parallel lines. You see by the arrows here that these 2 lines are parallel. And then these 2 lines on the opposite side here and here with the hash marks are congruent. So yes, you can draw a trapezoid with 2 congruent sides, and it's called an isosceles trapezoid. All right. That is your quadrilaterals lesson for today.